Hello everyone, welcome back to my YouTube channel. Myself Sai Vaishnavi BN, studying in Sri Venkateshwara College of Engineering in Department of Electronics and Communication Engineering. Semester is second semester, subject is Basic Electronics. Topic is PN junction diode. The contents I will discuss in this video are introduction, p-type and n-type diode symbol, biasing conditions, VI characteristics, properties, applications. PN junction diode introduction. On the basis of the type of impurities added, the semiconductors are classified as p-type positively charged and n-type negatively charged. When the p and n-types are fused together, it forms a PN junction semiconductor. When a PN junction semiconductor is affixed to an external voltage source, it is called a PN junction diode. The PN junction diode is an interface between an N-type and a P-type semiconductor material. The N-type has more electrons and the P-type has more holes. Deficiency of electrons or positive charge. An intrinsic semiconductor is a pure material made of elements from group 4 of the periodic table such as silicon and germanium. These elements have 4 valency electrons. P-type semiconductor. A p-type semiconductor is formed when an intrinsic semiconductor is doped with an electron-accepting element. For example, aluminum has 3 valency electrons, which when doped with silicon form 3 covalent bonds and 1 hole or electron vacancy is created. N-type semiconductor. An N-type semiconductor is formed when an intrinsic semiconductor is doped with an electron donor element. For example, phosphorus has 5 valency electrons, which when doped with silicon form 4 covalent bonds with 1 electron is free. PN junction diode symbol. The symbol of the PN junction diode is depicted as a triangle pointing towards a line or running through one vertex. This arrangement shows the direction of current flow in the circuit from the positive anode terminal to the negative cathode terminal. Biasing conditions in PN junction diode. In forward bias, the PN junction is forward biased when the P-type is connected to the positive terminal of the battery and the N-type is connected to the negative terminal. In this condition, the applied electric field and the built-in electric field at the PN junction are in opposite directions. Adding both the electric fields gives us a resultant electric field. Thus, the resulting electric field is found to be smaller than the built-in electric field. As a result, the depletion area becomes thinner and less resistant. When the applied voltage is high, the resistance of the depletion area becomes insignificant. At 0.6 voltage, the resistance of the depletion zone in silicon becomes absolutely insignificant, allowing current to flow freely over it. In reverse bias, the PN junction is reverse biased when the P-type is connected to the negative terminal of the battery and the N-type is connected to the positive side. In this condition, the applied electric field and the built-in electric field are both in the same direction. The resultant electric field and the built-in electric field are also in the same direction, resulting in a more resistive, thicker depletion area. Increasing the applied voltage results in a thicker and more resistant depletion area. VI characteristics of PN junction. The relationship between the voltage across the junction and current through a circuit is known as voltage ampere characteristics of a PN junction or semiconductor diode. Normally, voltage is measured along the x-axis, whereas the current is measured along the y-axis. The VI characteristics of the PN junction diode can be explained in three cases: zero bias, forward bias, reverse bias. No movement of holes or electrons occurs at zero bias state as no potential is applied externally, which prevents the passage of electric current to flow in the diode. In the PN junction diode is in the forward bias, a p-type is linked to the positive terminal of the external voltage while the n-type is connected to the negative terminal. This arrangement of diodes reduces the potential barrier, and the voltage is 0.7 volt for silicon diodes and 0.3 volt for germanium diodes. The potential barriers diminish and current flows. The current grows slowly while the diode is in forward bias, and the curve formed is non-linear because the voltage supplied to the diode surpasses the potential barrier. Once the diode has broken over the potential barrier, it operates normally and the curve climbs steeply as the external voltage rises, yielding a linear curve. When the PN junction diode is in negative bias, the P-type is linked to the negative terminal of the external voltage while the N-type is connected to the positive terminal, which leads to the higher potential barrier. Because minority carriers are present at the junction, a reverse saturation current occurs at first. Properties of PN junction diode. PN junction diode has the ability to rectify electric current. It can create a potential barrier and make use of its capacitance properties. PN junction creates various nonlinear current voltage characteristics in the semiconductor diode. The most important property is transforming light energy into electrical energy. The PN junction diode irradiates when the current flows through it. Applications of PN junction diode. Some of the most exciting applications of PN diodes are as follows. PN junction diode is utilized as a mode triple voltage doubler and quadruple in voltage multiplier circuits, as well as a switch in various electrical circuits. These are used in numerous circuit rectifiers and varactors for voltage control oscillators. The PN junction diode produces light when biased with a current, hence it is employed in light emitting diode and photodiode applications. PN junction diodes can also be used for another diode termed the light amplification simulated emission of radiation. In power electronics engineering, it can be employed in solar cells. Thank you for watching my video. If you like this video, please like, share and subscribe to my YouTube channel.